Alright guys, hi! Here we are for chapter 17. We're going to start with section 1 and maybe we'll get to 17.2. Alright, so first we are talking about the flow of energy, which our inquiry activity on Friday, which is today, we practiced. You had the rubber band, and when you stretched it, you should have felt it was warmer when you touched it to your lip or your forehead. And then when you relaxed it, it was cooler. So when our focus is on the rubber band, that is our system. And then everything else out of our focus is the surroundings. And we're going to talk more about that. Okay? So thermochemistry, you should be able to explain heat and energy, and work, their relationship, and classify processes as exothermic and endothermic. Okay, and here's our chemistry joke. Alright, energy transformations. What is chemical potential energy? Okay, hopefully you remember what potential energy is. And that's our stationary or stored energy. So the stored energy, where is it? It's in the chemical bonds of our substance. Okay, and when you have different kinds of atoms, and their arrangements in a substance, it will determine the amount of energy stored in the substance. So if you have one type of atom, okay, or a combination of atoms, and then you change even their arrangement, your second arrangement could have more energy than the first arrangement. And so in a chemical reaction, you have a substance transformed into another substance. Okay, you don't start with something and get the same thing at the end. And so when we transform our substance to something else, you end up with a different amount of chemical potential energy. Potential energy we also like to write as PE, okay? But it is very different than PE class. Alright, and then how does energy flow? Hopefully from our rubber band experiment, and I can grab one real quick. Okay, when the rubber band is our focus, this is our system. We pull it, and then your surroundings, your lips or your forehead, touch it. That's your surroundings. And so how do you determine the temperature? Is the energy flowing from one substance to another? And it's going to go from the warmer object to the cooler object. Okay, so here's a question for you. If you have two objects in contact with each other, one is hot and one is cool, how does the heat flow in this specific scenario? Okay, I want you to type your response in the box following our CER response that we just learned Friday. Okay, so make sure you give me your claim, your evidence, and your reasoning to support the link between the evidence and the claim. Alright, here we have endo and exothermic processes. Okay, endo means in, and exo means out. Therm means heat. So you have in and out heat processes, if you literally translate these. Okay, so again, we've got our system versus our surroundings. Okay, if you are talking and your focus is on yourself, you are the system. Everything else is your surrounding. Okay, so going along with this, we know about the law of conservation of mass. So now we have the law of conservation of energy. Okay, conserving energy. And so same wording, you just basically put energy in. In any chemical or physical process, energy is not created or destroyed. What you start with is what you end with. Okay, so that's pretty straightforward. If the energy in the system decreases, so if my energy decreases, my heat decreases maybe, then my heat is going into the surroundings. So the surroundings increase in energy. Okay, so it balances out. It's not created or destroyed. It's just moved. Okay. All right, and so then I've got examples for you at the bottom. Endothermic, if you are the system and you're sitting in front of a fire, like the picture in our book on page 506 points out to us, you are the system and you're absorbing heat from the fire. Okay, the heat is going into the system. Then it's an endothermic reaction. Okay, exothermic, okay, would be the heat going out of the system into the surroundings. So when you run, okay, you get really hot and sweaty, your heat is leaving your body and going into your surroundings. That is an exothermic reaction. Okay. All right. So here are two problems that I would like for you to answer. We'll do the first one together. So, on a sunny winter day, the snow on a rooftop begins to melt. As the melted water drips from the roof, it refreezes into icicles. Describe the direction of heat flow as the water freezes. Okay, so our system right now is the water. Okay, and so what direction is the heat flow on the water? It begins with melting, okay, so it's absorbing heat from the surrounding, and then when it drops down, so that would be an endothermic reaction, when it drops down and then refreezes into icicles, it's losing heat, okay, and so that would be exothermic. Try the next one for me and write your answer on the side. All right, so I know I played this joke for one section of chemistry on Friday, but I hope that this weekend you watch out for the enthalpy pirate, okay? He'll steal your jewels, okay? And so that would be horrible for prom this weekend. All right, have a great weekend and enjoy prom, guys. Bye.